Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to subscribe and share my videos to your friends and to your friends' friends. That's the only way you can help me promote my channel and to energize and keep me going. Determine the horizontal displacement at C by virtual work method and the horizontal displacement at D by Castigliano's second theorem. Take E 200 gigapascals and moment of inertia 400 times 10 to the 6 mm to the 4th. So in this figure, it's better to solve for RD and we section the three segments in this manner. And we consider all forces below and to the right of the section always. Although you can consider A going to right and vice versa. It's up to you. So by virtual work method, so we apply a unit rightward load at C. Then we solve for the reaction at D. Reaction at D times 2.4 equals 1 times 3. So considering the original frame, summation for SSX, that's 40, although this is not needed. What is needed is the reaction at D. So reaction at D, summation moment at A equals 0 times 2.4 equals 40 times 3. So the reaction at D is 40 times 3 divided by 2.4. That is 50 kilonewtons upward. So this is also 50 downward. So we section the original frame in this manner. And lastly, in that manner. Same is true with this. So this is 1.25. 1.25 is 1 times 3 divided by 2.4. So same sectioning. So remember formula, integral of capital M small m dx over EI. So EI delta C horizontal equals integral from 0 to 2. So the moment here is 0. So we proceed to this section here, 0 to 2.4. The moment is 50 times x, big M. For virtual forces, the moment is 1.25 times x dx over 1. EI is already there. Then, in this next section, the moment big M is 50 times 2.4, then minus 40 times x, that's big M. Small m is 1.25 times 2.4 at this section, then minus 1 times x. So integral 0 to 3 of 50 times 2.4 minus 40x, then 1.25 times 2.4 minus 1x dx. So using the calculator, the first integral is 208. The second integral after simplification is 360. So combining, delta CH is equal to 648 over EI, where EI is 200 times 10 to the 6 kilopascals times 400 times 10 to the 6 divided by 1000 to the 4th, or simply 200 times 400, and that is 80,000 kilonewton meter square. So the shortcut is we just divide by 80 to convert this to millimeters. So delta CH is 648 divided by 80. So it is equal to 8.100 mm rightward. Then by Castigliano's second theorem, the horizontal displacement at D, we apply a rightward force P at D as shown. And the reaction here is still, if we sum up moment about A, P is not involved because it passes through A, so the reaction at D would be 50. And it is not a function of P. So For CD, the moment is 50 times 0 plus p times x. The derivative is x dx, but p is 0, so in this section, the integral would be 0. So we proceed to this section here. So 0 to 3 of px times x dx, I just include it, but remember prior to integration we set p equals 0 because p is just invented, so that would be 0. So in this section the moment is plus integral of p times 3 plus 50 times x. P times 3 plus 50 times x, the derivative is 3, then dx. Derivative of this moment equation is 3. And lastly, in this section, the moment is integral of p times, this is 3 minus x. So p times 3 minus x plus 50 times 2.4 minus 40x, 0 to 3. So p times 3 minus x plus 50 times 2.4 minus 40 times x. Derivative 3 minus x. Partial derivative is 3 minus x. So setting the value of p to 0, so this is 0. This is integral of 50x times 3, or integral of 150x, 0 to 2.4. So that's 432. And this is 0, so 50 times integral of quantity 50 times 2.4 minus 40x times quantity 3 minus x dx. That is equal to 360. Combining, delta dh is equal to 792 over EI. So we divide that by 80 to convert that to mm. So delta dh is equal to 9.900 mm right torque.